Let's apply the power formula to calculate energy efficiency. So we know electric power is measured in watts, and watts are calculated by multiplying amps times volts. Let's use the power formula. P equals I times E to determine energy efficiency. P represents power in watts, or volt amperes, and I is the current in amperes times voltage in volts, known as E. Keeping this in mind, let's look at a common scenario where we can apply this power formula. I'm going to quickly sketch out a room, and this could be a bedroom or something, and I'm adding a space heater right here, and I'm going to add a hair dryer, and they're both plugged in. And I'm adding 3 lamps, one here, one in the corner over here, and in the other corner over here, and they're 60-watt incandescent bulbs. A typical room is wired with a 120-volt, 20-amp circuit. Well, it looks like I wrote it wrong, so cross that out. 20 amps here. There we go. We have a 1500-watt portable electric heater. We have the 1000-watt hair dryer. And then there's the 3 60-watt lamps with incandescent bulbs plugged into various outlets. So let's do the math by adding up these loads here. If we add the 1500-watt heater, the 1000-watt hair dryer, and the 3 60-watt lamps, the circuit draws 2,680 watts of power. Now let's apply the power formula. P divided by E equals I. We're going to write it out like this. So by dividing the power demand of 2,680 by the voltage, which is 120 volts, that leaves us with 22.33 amps being used. So let me clean the screen here, and as I'm doing this, I just want to say that we can make simple changes to create an energy efficient room just by replacing a few items. Okay, so I'm going to quickly sketch out the room again. Here's the space heater, right here, and we're gonna add that hair dryer again right over here. It's hard to draw freehand. We're going to have them plugged into the wall. And I'm going to add the 3 lamps again, over here, in this corner over here, and down here. Again, the bedroom is wired with 120 volts and the 20 amp circuit. However, I'm going to replace the heater with an energy efficient one, and it uses about 1,000 watts of power instead of the 1,500 watt models. So 1,000 watts for the heater. Okay, we're going to add the hair dryer again at 1,000 watts. And another easy and expensive way to reduce energy usage is to replace the 3 60-watt incandescent bulbs to energy efficient 13-watt compact fluorescent lights known as CFLs. And the 13 watt CFLs produce the same amount of light output as the 60 watt incandescent bulbs. So we're going to add the 3 13 watt CFLs here to the list. So let's do the math again by adding these up. We have the energy efficient heater at 1,000 watts, a 1,000 watt hair dryer, and then the 3 13 watt CFLs. So if we add that up, the power usage is now 2,039 watts of power. And when we apply the formula again, P divided by E equals I, we divide the power 2039 by the 120 volts, which leaves us with the 16.99 amperes of usage. Okay, so I'm going to clean the screen again really quick here. And we're going to compare the two. First, we have the original room versus the energy efficient room. The original room used 22.33 amps, and the energy efficient room used 16.99 amps. Notice the energy efficient room is under 20 amps of usage. So by using the power formula, we determined the energy being used. We replaced items for more energy efficient items. And we reduced energy usage. Now the room is energy efficient. So there you have it, an exercise of the power formula.